Hi, and welcome to Small Lab, an embodied learning environment. My name is David, and today I'll be walking you through a scenario that's called fluid interaction. The goal of this scenario is for students to learn about resources and about systems, and to do so through a play experience, working with each other and with a robotic companion. The system in this game includes water users and water producers, and the intent of the game is for students to keep enough water in the system for the duration of a level. If they're able to do that, the level will end and they'll progress on to the next level. If they're not able to keep enough water for the water users, they lose the game and can start over. This scenario uses two wands as well as the robot. And what I'm going to do now is walk you through the different components of the game so you get a sense of what you'll see, and then we'll move into how they interact. So the first thing is that we see a water reservoir. The image looks kind of like looks like a lake or a planet, and it has a ring of water around it. The second is a water user that we have here. The image itself looks like a house, and again there's a ring of particles which represent water that the house has. There's a timer which is counting down here at each level. It begins at a certain point and will count down to 0 when the level has expired. And then we also have a representation of the level itself. As we progress through the levels, of course, that will increment. What I want to do now is walk through the different kinds of behaviors that the robot has and start to articulate the ways that students can interact with the system. So mine and myself are working in the space with our robot. In a moment here, what you'll see is one of the behaviors that the robot has. The robot is going to try and move toward the reservoir. When the robot gets to the reservoir, it has this kind of icon of a circular motion, and what I can do is spin the robot around by moving above it. As I do that, you'll see that these different blue particles are emerging from the reservoir. And if I stop, what we're going to see is that the robot will gradually sort of wind down, getting slower and slower, and then it'll be done with its kind of drilling behavior that we have here. Now we also see that we have these particles now in the space, and I can start to interact with these by sort of pushing them over toward the houses. Mine and I can both do this, and the goal is to try and push those blue particles to the houses, which are the water users, in order to survive the level. So now I want to talk about a second behavior that the robot has. In this case, the houses are going to periodically emit wastewater particles. When they do that, the robot is actually going to try and track down those wastewater particles, collect them, and bring them back to the reservoir. When it returns to the reservoir, those wastewater particles are recycled and then available to be distributed through the system again. So mine and I are going to play the game now and talk a little bit about what we're doing as we're playing it to give you a sense of how the interaction works. Again, mine and I are playing cooperatively along with our robotic companion. So when the game starts, again, the robot is going to go to the reservoir. I'm going to go over and spin it around to release water into the system. Mine and I are both going to take these blue particles and try and push them over to the house. You see that the house right now just has a few particles, and in order to win this level, what we want is for it to be full of water particles and essentially to have enough water to remain alive for the duration of the level as it's ticking down. You notice that the robot now has left the reservoir and it's going over to track down these wastewater particles. Once it has that, it's going to now try and return to the reservoir to recycle that particle. Again, my goal here is to try and push water particles over to the house to keep it full. And now I'm going to release some more. And having completed that level, time went to 0. We maintained enough water within the house itself, and now we move on to the next level. In this case, we might see that we'll get more water users, but the amount of resource remains the same. As the levels progress, of course, it gets more and more difficult to maintain equilibrium within the system. So it goes to the reservoir. Mine can spin it around in order to release these particles. Again, I'm going to help out by pushing these particles over to the house. And again, our goal here is to work together to try and maintain the system as long as we can. Notice that mine continues to spin the bot. As new particles come into the reservoir, they'll emerge, but when it's empty, nothing will come out. So students are kind of developing an understanding of how the system works through this kind of play again. So now you see that we've progressed to level 3, and what we want to demonstrate is a way in which we don't actually succeed in maintaining equilibrium in the system. So our robot has gone to the reservoir, and we're not actually going to drill any water out of it. So we see here that this house has a certain number of particles in it, but again, it's emitted particles, and we'll see this count down. The robot is chasing after those. As we see here on this house, we have just 4 particles, and again, if we run out of particles, run out of water for that user, we're going to lose the level. So the bot is chasing these. We're missing our opportunities to draw water out of the reservoir. And as we do that, again, we're going to see that the clock is going to tick down. Our water consumers are consuming more and more water as the level progresses. And in this case, we have 85 seconds left to try and maintain equilibrium, and we're probably not going to make it if we run out of water. So now we have 44 seconds left in the level, but we see that our water user here has only one particle left. They actually, in fact, both only have one particle. If we totally run out of water on this level, we're going to lose this level and play the game again. So now I'd like to talk about a sort of advanced feature of this system, which is that as players are playing the game, they in fact are even changing the way that it functions. So one thing, if I draw some water out of this reservoir, and I start pushing particles around, what you'll see emerging are these blue arrows. These are actually kind of flow channels that emerge over time, and they're dependent on the way that I interact. If I push this really forcefully toward the house, you'll see that these will increase in magnitude. Over time, this kind of infrastructure that players are building as they play starts to change and reshape the way that the board in fact flows, how particles move through the system. As students play the game, each level will get progressively more difficult, with fewer resources available and more demands on that resource. There are a total of 9 levels in the game.